In the times ahead, we're facing some big what-ifs that could shake things up, whether they be natural or man-induced. From scary stuff like nuclear problems and giant space rocks to global fights and not having enough water, the future has its share of potential disasters and catastrophes. Imagine a world where a really bad germ spreads everywhere, or where super smart computers start causing trouble, or even a huge burst of sun power messing with our tech. These are the kinds of things we're thinking about, not to scare you, but to get us all thinking. Let's take a peek into these 10 potential catastrophes and think about how we can be prepared for whatever might come our way. Number 1. World War III Explosion. The potential occurrence of a Third World War casts a dark shadow over humanity, presenting a specter of devastation more profound than any conflict we have faced before. Did you know that a recent survey by the American Psychological Association revealed that almost 7 in 10 Americans harbor concerns that we might be entering the initial phases of World War III? Furthermore, some experts interpret this collective anxiety as a signal that we stand on the precipice of a potential crisis. While opinions may differ on the definition of a world war, it typically entails 2 significant alliances vying for supremacy, drawing in multiple nations on each side engaged in armed conflict across various theaters. Regardless of the validity of these concerns, it is crucial to understand the repercussions of such a catastrophic scenario. Unlike past wars, the weaponry envisioned for such a scenario transcends the bounds of conventional warfare, taking us into the realm of advanced technology that could magnify the destructive impact manifold. Nations such as North Korea and Russia proudly display their military might in grand parades, instilling fear in most observers. If the visible demonstrations are unsettling, one can only imagine the potential dread associated with undisclosed technologies. The most potent and strategic weapons are likely held in secrecy. Consider the hidden arsenals within the Pentagon or the Kremlin base. What kind of lethal technologies might be concealed from public view? This brand new war will try to preserve the lives of soldiers. I mean, who wants to put lives at risk when you have unmanned aerial vehicles that you can use? An unmanned aerial vehicle, or UAV, or drone for friends, is an aircraft designed to operate without a human pilot or passengers. These vehicles, fully or partially autonomous, are typically controlled from a distance by a human pilot. In a World War III scenario, these might be equipped with artificial intelligence, capable of autonomously identifying and targeting enemies with unprecedented precision. Hypersonic missiles move at speeds many times faster than sound, rendering traditional defense systems obsolete. Cyber warfare reaching new heights, disrupting crucial infrastructure, financial systems, and communication networks on an unprecedented scale. But even in the case, a manned operation would be necessary. Soldiers will be equipped with amazing suits, very different than the ones we are used to nowadays. For instance, they could employ exoskeleton suits. These are like wearable robots that you put on your body. They're designed to make you stronger or help you move more easily. Suits like these have motors or other mechanisms to make movements more powerful. In the military, soldiers might use exoskeleton suits to carry heavy things without getting tired quickly. This would certainly turn the battlefield into a dystopian theater of augmented warfare. Moreover, nanoscale weapons and biological agents could be employed, heightening the lethality of conflicts and leaving lasting, devastating impacts in both the environment and human populations. The aftermath of such a catastrophic event is deeply unsettling to consider. The human cost, with lives lost and cities turned to rubble, is profound. Crucial infrastructure like buildings, roads, and bridges may face severe damage, presenting a daunting challenge for communities to rebuild. The extent of destruction could surpass that of previous conflicts, not only impacting combat zones but also affecting regions indirectly touched by the war. Furthermore, the deployment of advanced weaponry, including nuclear or biological arms, could lead to enduring environmental consequences. Radioactive contamination, chemical pollution, and disruptions to ecosystems might render certain areas unsafe for human habitation, posing significant hurdles for biodiversity recovery. In comparison, the fallout from this event would by far surpass the magnitude of the Chernobyl disaster. Speaking of nuclear weapons and related problems, have you ever wondered what will happen in the case of a big nuclear disaster? Number 2. Nuclear disaster. Nuclear facilities around the world, if not managed properly, have the potential to unleash devastating consequences. These facilities are designed to harness the immense power of nuclear reactions for electricity generation. However, accidents, technical failures, or natural disasters can lead to catastrophic events, releasing radioactive materials into the environment. The repercussions of such incidents extend far beyond the immediate vicinity of the affected site. The Chernobyl disaster in 1986 reminds us of the worst-case scenario in nuclear accidents. The explosion and subsequent meltdown of the reactor released a significant amount of radioactive materials into the atmosphere, contaminating large areas and causing long-term health and environmental effects. The immediate region around Chernobyl remains uninhabitable to this day. This event had a strong impact on the flora and fauna around the area, but it also extended further due to the rise of a radioactive cloud that eventually came down, driven by winds. Radiation exposure at Chernobyl has been linked to the occurrence of albino animals in the region. This includes albino birds, rodents, and insects. The genetic mutations induced by radiation can alter pigmentation, leading to the development of these unique and visually striking individuals. There have also been reports of abnormally large catfish. Some speculate that the absence of human activity and limited fishing in the area, rather than radiation-induced growth, has allowed these fish to reach larger sizes compared to those in other bodies of water. For humans, the situation was even grimmer. One of the extensively documented impacts on the population has been a substantial rise in cases of thyroid cancer, especially among those who were children at the time of the disaster. The release of radioactive iodine-131 during the accident contaminated local food sources, resulting in an increased prevalence of thyroid cancer. Individuals exposed to high levels of radiation during and after the Chernobyl disaster have reported a range of health issues, including a heightened risk of leukemia, cataracts, and cardiovascular diseases. Contemplating the possibility of a nuclear disaster more severe than Chernobyl raises daunting questions about humanity's recovery. While the likelihood of recovery is plausible, the affected regions would necessitate several decades, if not centuries, to regain some semblance of normalcy. The enduring consequences of such a catastrophic event would pose significant challenges to both immediate and long-term human well-being. As you can understand, it is crucial to stay informed about developments in nuclear safety and monitor international efforts to prevent future nuclear disasters. Number 3. Killer asteroid. Astronomical data suggests that a significant asteroid impact capable of causing widespread devastation occurs approximately once every few 100 million years. While the likelihood of such an event is low, the potential consequences could be terrible. A large asteroid impact would generate immense shock waves and heat. Then, depending on the impact site, the asteroid could trigger massive fires, generating firestorms and releasing debris into the atmosphere. Not only that, if an asteroid were to strike an ocean, it could generate colossal tsunamis that would devastate coastal areas. Is there any way humans could survive this? The answer is probably yes, but they will have to evacuate their homes and live in bunkers. Bunkers are often considered a potential refuge, offering the population some temporarily safe shelter. However, the feasibility of accommodating the entire global population presents challenges in terms of construction, maintenance, and resource allocation. It's very likely that only very rich people or governments will be lucky enough to enter one of these bunkers. But even for them, a time will come when stored food sources will run out. In a post-impact scenario, mushrooms could constitute a notable resource. Their cultivation in controlled environments and efficient conversion of organic matter into edible biomass makes them a perfect choice. The asteroid debris cloud would obscure the sun for a long period of time, but the good news is that mushrooms require very little amount of light to prosper. Moreover, they are rich in nutrients and are adaptable to recycled waste. Recognizing the potential threat posed by asteroids, international space agencies such as NASA and the European Space Agency have established dedicated programs for planetary defense. These initiatives focus on monitoring near-Earth objects and assessing their impact probability. Utilizing advanced telescopes and probes, these agencies contribute crucial data for identifying and tracking asteroids, allowing for the computation of potential collision scenarios. Tasked with identifying, tracking, and characterizing potential hazardous asteroids, these offices collaborate with international partners. Ground-based observatories and space-based assets are utilized to enhance our understanding of potential threats. The offices are also engaged in the development of strategies to deflect or mitigate the impact of potential killer asteroids. Number 4. Water scarcity. In a world where water, the essence of life, should be abundant, alarming statistics paint a bleak picture. Severe water scarcity affects a staggering 4 billion people, nearly 2/3 of the world's population, for at least 1 month annually. Over 2 billion people reside in countries grappling with inadequate water supply. Shockingly, projections indicate that by 2025, half of the world's population could find themselves living in regions plagued by water scarcity, with a potential displacement of 700 million people due to intense water scarcity by 2030. The gravity of the situation deepens further as, by 2040, 1 in 4 children globally is expected to inhabit areas characterized by extremely high water stress. This essay delves into the unfolding global water crisis, exploring its causes, consequences, and the urgent need for collective action. Major cities like Sao Paulo, Chennai, and Cape Town have recently grappled with acute water shortages, narrowly escaping what is ominously termed Day Zero, a day when taps run dry. According to Betsy Otto from the American World Resource Institute, WRI, more such days may loom in the future. The WRI highlights the Middle East and North Africa, with Qatar at the forefront as regions facing the highest water stress. So where does water scarcity come from? It is a consequence of a complex interplay of human and ecological factors. Climate change exacerbates the issue as increasing periods of persistent heat attributed to global warming lead to the drying out of water sources. Floods, another consequence of climate change due to rising sea levels, further threaten water availability and quality. Large-scale water wastage and pollution compound the problem, accentuating the challenges posed by a growing global population. Living in the shadow of water scarcity carries dire consequences. Deprived of access to clean water, populations in affected areas resort to using polluted water, leading to diseases such as diarrhea, worms, and cholera. Shockingly, diarrhea remains the leading cause of death among children under the age of 5 in developing countries. Beyond the immediate health implications, water scarcity indirectly perpetuates poverty. Individuals, particularly women and young girls responsible for fetching water, are unable to attend school or work due to illness, perpetuating a cycle of hardship. In the not-so-far future, water will probably become a precious commodity. Regions facing scarcity are vulnerable to geopolitical tensions and conflicts. The construction of dams, as witnessed in the Middle East by countries like Iran and Turkey to meet their water needs, will have major consequences. Nations like Iraq and Syria pay a steep price in the form of drought, social unrest, and conflicts. This is why it is so important to promote sustainable water management practices and ensure equitable access to this vital resource for all. The fate of our shared future depends on our ability to confront this impending crisis and forge a path towards water security. Hey, before moving on, be sure to like or dislike the video so that we can improve them for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. Number 5. Cascadia Event. The Cascadia subduction zone, spanning from southern Canada to northern California, marks a geological hotspot with the potential for future and powerful seaquakes. It involves the subduction of the Fuca plate beneath the North American plate, covering a distance of approximately 800 miles. Unlike other fault lines that cause frequent, smaller earthquakes, Cascadia remains silent for years, making it challenging to detect. Scientists warn that stress is building along the Cascadia subduction zone, with a looming potential for a mega-thrust earthquake. The last such devastating event occurred in 1700, and scientists believe these earthquakes have a recurrence interval of several centuries. If a substantial earthquake hits, the consequences could be severe, with ground shaking, tsunamis, aftershocks, and widespread infrastructure damage. Drawing comparisons with historical events such as the 1994 earthquake along the San Andreas Fault underscores the potential danger of a Cascadia earthquake. While the 1994 event caused significant damage, the Cascadia subduction zone could experience a much larger earthquake, potentially exceeding a magnitude of 9.0. The accompanying tsunamis could magnify the impact, making preparedness and response more challenging. Interestingly, the Cascadia subduction zone's discovery only occurred around 50 years ago. Before that, its silent threat went unnoticed. The revelation came through its location along the Ring of Fire, a zone of volcanoes and faults encircling the Pacific Ocean plate. Historical evidence, including a ghost forest in Washington and Japanese records of a mysterious tsunami in 1700, provided insights into past Cascadia earthquakes. Surviving a Cascadia earthquake involves not only understanding ground shaking, but also preparing for potential tsunamis. Lessons from history, like the 1960 Chilean tsunami measured by seismologist Jerry Eaton and his team in Hawaii, emphasize the importance of timely evacuation to higher ground for safety. Communities are implementing early warning systems, strengthening buildings, and educating people on earthquake preparedness. We just published a video about Cascadia. Be sure to not miss it. Number 6. Magnetar radiation bursts. Magnetars belong to the family of neutron stars, remnants of massive stars that have undergone supernova explosions. What sets magnetars apart is the incredible strength of their magnetic fields, trillions of times more powerful than Earth's. These extreme magnetic fields give rise to phenomena such as X-ray bursts and occasional outbursts of gamma-ray radiation. Thankfully enough, these objects are relatively rare. It's estimated that there could be around 30 magnetars in our Milky Way galaxy, although their exact count remains uncertain. Their scarcity is attributed to the specific conditions required for their formation, making them distinct among the diverse stellar remnants scattered across the cosmos. A magnetar's impact on Earth would get stronger with the inverse of the distance squared. If one were 1/5 that distance, the impact would be 25 times stronger. Some of the magnetars near Earth include AXP 1E 1048-59, which is located about 9,000 light-years away in the constellation Carina, SGR 1900 plus 14, 20,000 light-years away in Aquila, SGR 1806-20, 50,000 light-years away in Sagittarius, and SGR 0525-66, 165,000 light-years away in the Large Magellanic Cloud, just outside the Milky Way. These distances are obviously far beyond anywhere we've explored in our galaxy, or even sent probes like Voyager 1 or 2 to visit. If you ask an astronomer, many will say that magnetars are among the scariest objects in the galaxy. Certainly you don't want to be near one, but the massive blasts of energy they produce can impact us here on Earth despite their great distance away. While the chances of a magnetar directly causing harm to Earth are minuscule, the hypothetical scenarios are intriguing and unsettling. The most alarming potential threat is through a relatively close encounter with a magnetar, which could disturb the Earth's magnetosphere, the protective shield caused by its magnetic field. This disturbance might lead to a cascade of consequences, including disruptions to power grids, satellite malfunctions, and even atmospheric effects. The likelihood of a magnetar directly causing human extinction is remote. However, the secondary effects of a significant disruption to Earth's magnetosphere could have severe consequences. Widespread power outages, communication breakdowns, and disruptions to critical infrastructure could lead to chaos and societal challenges. Number 7. Kessler Syndrome. Named after NASA scientist Donald J. Kessler, the Kessler Syndrome refers to a theoretical scenario in which the density of objects in low Earth orbit, LEO, becomes so high that collisions between objects could lead to a cascade effect of further collisions. This could generate a cloud of debris that poses a significant threat to operational satellites and spacecraft. If all assets in orbit were destroyed by space debris, the consequences would be big. Communication systems, navigational tools, weather monitoring, and scientific research heavily rely on satellites in orbit. The loss of these assets could lead to disruptions in global communication networks, compromised weather forecasting, and a significant setback to scientific endeavors dependent on orbital platforms. For instance, take the airline industry. It uses a system called Flight Management System, FMS, to make flying smoother by automating tasks that used to be done manually. FMS relies on sensors, including GPS, to figure out where the airplane is and how much fuel it has. If the satellite communication system has a problem, it could mess up the GPS data and make the flight management system not work properly. Even though airplanes have backup sensors to help with landing in case of issues, relying only on old-fashioned communication during lots of flights could be risky. If this happens, talking between air traffic control and airplanes might be really difficult, affecting how flights are managed and how they deal with emergencies. Without access to satellite communication systems, pilots would not be able to receive real-time weather updates, leading to potential risks of navigating under hazardous weather conditions. In the marine industry, ships heavily rely on advanced systems to navigate safely and avoid collisions during their journeys. Precision agriculture, a game changer in farming, also depends on satellites for tasks like farm planning, tractor guidance, and yield mapping. The smooth functioning of satellite communication systems is vital for efficient and sustainable agricultural practices, ensuring global food production. The impact of losing satellite communication on the agricultural sector is explored in later sections. Even medicine is connected to satellites. Though it might not seem obvious, modern medicine relies on satellite communication for storing and retrieving patient data efficiently. Understanding the seriousness of the Kessler Syndrome, space agencies are actively working to manage orbital debris and prevent the syndrome. This involves developing technologies to track debris movement, creating guidelines for responsible satellite deployment and disposal, and exploring innovative concepts like debris removal missions. A study from the University of Buffalo suggests short-term and long-term solutions. Short-term focuses on removing immediate threats by deorbiting and burning debris. However, burning debris could harm the ozone layer, creating new risks. Therefore, a long-term approach emphasizing recycling is essential. Researchers propose innovative methods to recycle space debris into useful materials, like fuel and artificial soil, offering cost-effective and sustainable solutions without harming the environment. Number 8. Global pandemic. The global pandemic, as experienced with COVID-19, has highlighted the potential for widespread disaster on a global scale. The COVID pandemic, caused by the novel coronavirus SARS-CoV-2, led to significant health, social, and economic consequences worldwide. Pandemics caused by respiratory viruses similar to COVID-19 remain a considerable concern. These viruses spread easily through respiratory droplets, making containment challenging. Consequences include overwhelmed healthcare systems, economic downturns, and social disruption. Lessons from the COVID-19 pandemic emphasize the importance of early detection, robust healthcare infrastructure, and global collaboration in vaccine development. Another type of pandemic that poses a significant threat is zoonotic, where diseases jump from animals to humans. Examples include the avian flu, H5N1, and the swine flu, H1N1. These pandemics can be particularly challenging due to their unpredictable nature and the potential for rapid transmission. The consequences involve strain on healthcare systems, economic disruptions, and in severe cases, significant loss of life. The rise of antimicrobial resistance can also lead to pandemics where common infections become challenging to treat. This scenario could result in increased mortality rates, strain on healthcare resources, and a potential reversal of medical advancements. Efforts to address antimicrobial resistance and develop alternative treatments are crucial in mitigating such a threat. While not biological, cyber threats can also create pandemic-like disruptions. Cyber attacks on critical infrastructure, healthcare systems, or communication networks could lead to widespread chaos. Consequences may include compromised healthcare delivery, economic turmoil, and societal unrest. In order to understand what a pandemic could do to us, consider the influenza pandemic of 1918, often referred to as the Spanish flu. This stands as one of the worst pandemics in recorded history. It occurred during the final stages of World War I from 1918 to 1919 and had a profound impact on global health. The Spanish flu spread rapidly across the globe, affecting nearly every country. The movement of troops during World War I contributed to its swift transmission. The mortality rate was exceptionally high, with estimates suggesting that around 1/3 of the world's population was infected, and the death toll reached tens of millions. The virus was particularly lethal for young, healthy adults, which was unusual as most influenza viruses tend to affect the very young and the elderly more severely. The lessons learned from the Spanish flu have contributed to the development of modern influenza surveillance and preparedness measures to mitigate the impact of future pandemics. It is important to note that since viruses can mutate and become more virulent, we can't expect pandemics to occur in multiple waves. This is why in addressing these potential pandemics, global preparedness is key. It is also crucial to invest in healthcare infrastructure, surveillance systems, and research for early detection and response. Number 9. Artificial intelligence takeover. A recent survey from Stanford University revealed that over 1/3 of researchers fear that artificial intelligence, AI, could lead to a catastrophic event similar to a nuclear disaster. This concern is part of the 2023 AI Index report, which explores the latest developments, risks, and opportunities in AI. AI systems have made remarkable progress, excelling in tasks like answering questions and generating text, images, and code. However, the report highlights that these systems can have issues like hallucination, biases, and susceptibility to manipulation for malicious purposes. This raises important ethical questions about how we deploy and use AI. The call for regulating AI has grown louder due to controversies involving AI, such as incidents linked to chatbots and the creation of deepfake videos. Influential figures like Elon Musk and Steve Wozniak are among those urging caution, suggesting a pause in training AI systems until we are more confident about their positive impact and can manage potential risks. The survey included experts in natural language processing, a crucial aspect of AI development. While 36% of researchers expressed concern about AI causing a catastrophe, a larger group, 73%, believed that AI could lead to significant societal changes. Public opinion on AI varies globally. In the United States, only 35% of people think that products and services using AI have more benefits than drawbacks. In contrast, respondents from China, Saudi Arabia, and India are more optimistic, with 78%, 76%, and 71% respectively seeing more benefits. As AI encounters more incidents and controversies, the need for responsible development and ongoing ethical scrutiny becomes crucial. The Stanford report signals a pivotal moment for the AI community, emphasizing the importance of collectively navigating the challenges and opportunities presented by this rapidly evolving technology. Number 10. Carrington-like solar storm. Solar storms, or space weather events, occur when the sun releases immense bursts of energy in the form of solar flares and coronal mass ejections, CMEs. These phenomena are driven by the sun's complex magnetic activity and can have profound effect on our technological infrastructure. So why exactly do they take place? The sun's magnetic field is constantly shifting and rearranging itself. Sometimes this leads to the release of vast amounts of energy, resulting in solar storms. The main actors in this cosmic drama are solar flares, intense bursts of radiation, CMEs, massive clouds of solar plasma, and magnetic fields. What could be the troubles caused by a solar storm? Well, there's a few. Solar storms can interfere with Earth's magnetic field, causing geomagnetic storms. These storms, in turn, can disrupt satellite communications, GPS systems, and power grids on the ground, leading to widespread technological failures. Moreover, astronauts in space or those aboard high-altitude flights can be exposed to increased levels of radiation during solar storms, posing health risks. In 1859, the Earth experienced one of the most potent solar storms in recorded history, the Carrington Event. Named after the British astronomer Richard Carrington, who observed and documented the solar flare responsible, this event caused widespread disruptions. Auroras were seen around the world in both the northern and southern hemispheres during the Carrington Event. The aurora over the Rocky Mountains in the United States was so bright that the glow woke gold miners, who began preparing breakfast because they thought it was morning. People in the northeastern United States could read a newspaper by the aurora's light. The aurora was even visible from the poles to low-altitude areas such as south-central Mexico, Cuba, Hawaii, Queensland, southern Japan, and China, and even at lower latitudes very close to the equator such as in Colombia. During the Carrington event, telegraph systems around the world malfunctioned, some even sparking fires due to the intense electromagnetic activity induced by the solar flare and giving operators electric shocks. If a similar event were to occur in the present day, our interconnected and technology-dependent world could face unprecedented challenges, with potential disruptions to communication, navigation, and power grids. A solar storm. What an amazing, yet terrible cosmic event. In contemplating the myriad potential catastrophes looming over our planet, it's evident that life, a delicate product of the universe, demands our vigilant care. While some disasters lie beyond our control, there's tangible power in our ability to prevent and mitigate the impact of artificial catastrophes. Through proactive measures and dedicated care, we hold the key to preserving the longevity and prosperity of life on Earth. That's all for this video. What would you like us to cover next? Feel free to share your thoughts in the comments below, and stay tuned for our next video. We'll see you soon on the channel.